Hey everyone, welcome back to another lesson. This is part two. Hopefully you watched part one, or else why would you watch part two? That doesn't make sense. Go back and watch part one. This is part two of slopes of lines, and today's topic is centered around coming up with an equation for a line that's parallel or perpendicular to another one. Okay? We're just going to jump right into it. When coming up with an equation of a line, we put that in what's called slope-intercept form. Now, this is a review from Algebra 1. I'm not going to dive too deep into of this topic because, well, that was kind of last year's topic. But let's just do a quick review. So this is called slope-intercept form. Now, why do they call it that? Well, for one thing, there's a slope, and slope is going to be represented by the m value, and there's an intercept, specifically the y-intercept, which is represented by the b value. Okay, if I had this line right here, and I said, okay, what is the equation of this line going to be? Well, just by visual inspection, I can see, well, maybe you can see, it's very tiny. Let's zoom in. There we go. Come a little closer to the board. I can see that it crosses the y-axis at 2. So my b value is 2. And my slope, I can actually count points. So starting from here to this point up here, I rise by 1, and I went over by 1. So my slope is just going to be a 1. Or some people might say, well, isn't it just 1 over 1? Rise 1, run 1. It is, but you can leave it as that. The equation for this guy then has to be 1x plus 2. Okay? Think of the y-intercept as a starting point. This is where my graph starts. And then I use the slope to extend it to the right and to the left, okay? Now, here's another thing to bring up. If I were to pick a point that's on this line, okay, and plug it into here, it'll make this equation result in a true expression, okay? That's important for what we're going to talk about in the next part of this lesson. Let's just pick a point. So let's pick, I don't know, let's say 2, so that's 0, 2. This would be 3, 1. This would be 4, 2. So let's pick 4, 2. Okay, 4, 2 is actually on the graph here. And what I'm going to do is plug it into here and verify that it is going to work. And it will. Okay, this is my x value. This is my y value. Substitute these guys into here. I get 2 equals 1 times 4 plus 2. Oh, actually, let me. Oh, jeez. I flipped them. I'm so sorry. You're probably screaming, wait, that's not the right point. It is now. I flipped them in my head. I apologize. So it's the points 2, 4 is what I'm looking at. Okay, and if I plug these in, I can see that 4 is going to equal to 4. It's going to work, okay? So no matter what point I pick, as long as it's on a line, it'll make this guy true. Okay? Questions, thoughts, concerns? Look familiar? It should. Okay, let's go ahead and dive into some examples. I want to keep that board. Just move it off to the side. Sorry. Different math problem. Okay, and well, you're too close right now. You gotta back up. Just back up. Just a little bit. Just a little bit. Okay, you're good. You're good. Just give me some space, guys. That's all I'm asking. Okay, we're going to do 3 examples today. And then that's it. Okay. I have a lot more examples in my notes you can feel free to look at, but this will at least get you an idea as to what's happening. First one, okay, we're going to write an equation in slope-intercept form. I'm going to abbreviate, okay, for a line that passes through -1, 1 and is parallel to the line y equals 2x minus 1. Okay? Let's break this down a little bit. Slope-intercept form. I want to create a line that is in that format. So we're looking at this guy, y equals mx plus b. That's what the first part reads. What I know is that this line that I don't know about yet, all right, by the way, it goes through that point, so that's part of it. And then the last part is it's parallel to this line. This is not the equation, by the way. It's just whatever my line is that I haven't figured out yet, it's parallel to this guy. Okay? All right. Let's solve this. You need two things to write this equation. I need a slope and a y-intercept. Let's focus on the slope part, okay? This line is parallel to this guy. Now, if you remember from the last lesson, parallel lines have the same slope. The slope of this guy is 2. So that means the slope of my line is also going to be 2. I'm going to put this in parentheses. Since it's parallel to this line. Okay? A little note just so I know why I picked it to be 2. It's parallel to this line. That's why it's the same. Okay. I'm done with that part. Now, the next thing is the y-intercept. Where does it start? Now, you could do a couple things here. I know it goes through this point, right? And I know what the slope is. So technically, I could graph points and see where it crosses the y-axis. You could do that. The only downside is, what happens if the y-intercept is not a whole number? That could be problematic. Remember what I did at the very beginning of this lesson. Okay? I made the statement that whatever point is on this line will make this guy true. If that's the case, let's say I didn't know what b was for this guy. I just put a variable there. Let's just put b. If I plug these points in with the slope, I can figure out what b is, huh? That would make this guy true. I have all my components there. Why not do that? Looking at this guy, I have a point that it goes through, okay? So my point's negative 1, 1. It has an x and y value that I could use. I know what this is. So if I plug these numbers into here, there's only one thing that I don't know, and that's b. And I could solve for that. And I know then where it crosses the y-axis. Let's go ahead and substitute. We have 1 equals, the slope's 2, times the x value, which we know is negative 1, plus b. Remember, b is the y-intercept. I don't know what that is yet. Now solve. 1 equals negative 2 plus b. Now for my last step, to get b by itself, I would add 2. That's going to cancel the negative 2 out. I get 3 equals b. Now just be careful, that's not the answer. Okay, don't get too excited right now. We're close. Okay, you could be sort of excited. Go ahead. You could be happy about that. I have a slope. I have a y-intercept. I have everything that I need now to create this equation for this line. Let's put it together. 2x plus 3. There's my equation. Let's compare them. So here's the two lines. Are they parallel to each other? Yeah, they are. This has a slope of 2. This has a slope of 2. They have different y-intercepts, which is perfect, because if they didn't, it's the same line. That doesn't work for us, right? Therefore, these guys have to be parallel to each other. Okay? Now, could you plug this point back into here to see if it works? Absolutely. In fact, why not? Let's try it out right now. We have 1 equals 2 times negative 1 plus 3. Negative 2, right? Plus 3 gives me 1. Does 1 equal 1? It does. So it works. That's why they give you a point, and that's why they give you another line to compare it to. I have all these clues as to what this line is. All you need to do is put it together. Pretty cool, huh? Okay, ready to do something different? Example 2. You're probably going to guess what I'm changing. We're no longer talking about parallel. We're going to talk about perpendicular. So this example is going to talk about perpendicular lines. Okay? let's see. Okay. New problem. Write an equation in slope-intercept form for a line that passes through this point, -2, -3, and is perpendicular to this line. Okay. Key point being perpendicular to that line there. And once again, this is just something to compare the line that we don't know to. All right. That's all this is there for, and it's to help us find slope. If you remember from perpendicular, that means my slopes are opposite reciprocals. Okay, I'm abbreviating a lot. That means that the signs of both numbers are different and the reciprocals of each other. If I take one of the numbers and flip them, I will get the other number. Okay, that's a property that we've discovered with perpendicular lines. To create my equation, I still need a slope and y-intercept, no matter what. Okay, that's where this guy comes in. This mysterious line is perpendicular to this guy. Okay, now, what's the slope of this guy? It's a -3. I'm going to put it over 1. It means the same thing as -3, right? I just need that for comparison to help us see this more visually. Now, the slopes are opposite reciprocal if they're perpendicular. So I'm going to take this guy, I'm going to change it to a positive, and then I'm going to take it and find its reciprocal by flipping it. So 1/3. My mysterious line that I'm trying to create has a slope of 1/3. Okay? And the reason why it does is because now it's perpendicular to this guy's slope, because it follows this relationship. A lot of people have a hard time with the perpendicular side to things, so just take a minute. Think about what I just said there. Okay? All right. Now I need a y-intercept. That's where this point helps us with it, right? This line has this point, and this point will make this guy work, right? If I go back to this example here, and let me change that back to its original, 2, 4 made this guy work, okay, because it was on the line. Same principle, except I don't know what b is, but I can solve for it. Okay? All right. Let's go ahead. I know what m is. It's 1/3. I know an x and y value that works for this. All I don't know is b. Let's substitute. We get -3 equals, the slope is 1/3 times a -2. I'm going to put that over 1 for right now, plus b. Remember, -2 and -2 over 1 are the same thing. All right? Not different. I get -3 equals, now, when I multiply these two fractions together, you see why I put that over 1? It's easier to see when you multiply. You get -2/3 plus b for that guy. Now we're going to solve for b. I'm going to add 2/3 to both sides. That will cancel this guy out. And then add 2/3 over here. Now, here's the deal. A lot of people are going to be like, you know what? I'm just going to make it a I'm going to make a decimal and figure it out. You could do that. It's 1/3. That means you're going to have to round, okay? I want to keep it as a fraction, and it's good practice to work with fractions, quite honestly. Common, excuse me. Okay, back to it. Common denominator would be 3, right? This guy's good. Multiply top and bottom by 3 here. There we go. Okay, we got enough space. And I would get -9/3 plus 2/3 equals b. I'm out of space. I'm going to write it up here. I get -7/3 as my b value. Okay? Like I said, when you see thirds coming up, probably wouldn't round or do a decimal. Just leave it as a fraction. You can work with it. Okay? Now, I have everything I need to create this equation, this mysterious line that goes through that point and it's perpendicular to here. So the answer is going to be y equals 1/3 x, and it'll be -7/3. And that's it. What do you think? Any questions on that? Same process, right? I didn't change the process. The only thing that did change was this guy, right? It was perpendicular, so it wasn't the same slope as this. I had to change it, so that way it was perpendicular. Okay? All right, one more to go, and we'll get 15 minutes. We're making good time. What about this problem? Okay. The question is, show that triangle LMN is a right triangle. Okay, that's what we're going to try and do in this example. I have 3 points. I just drew a very rough graph of what it looks like. Okay. Based off the graph, where would I put that 90-degree angle at? I'm going to say what? Right there. Okay, that's probably where I'm going to put it, right? Because of that, these two lines must be perpendicular to each other to create that right angle. And I need a right angle because I'm trying to prove that this is a right triangle. Okay, there's more than one way to actually prove this. For those who are watching this and are thinking, hey, I think Pythagorean theorem can do it. You'd be right. But for right now, we're going to use slopes. So what I'm going to do is calculate. Here's my approach. I'm going to calculate the slopes for line LM and MN. Okay? If they're opposite reciprocals of each other, they're perpendicular, that's a 90-degree angle, therefore this is a right triangle. If it doesn't, then I know for a fact that this is not a right triangle. Okay? Let's go ahead and do that. I'm going to use just a small notation. M's for slope, right? And then LM, I'll put as a subscript. That way it's easier to see what slope I'm looking at. I know it's rise over run. Subtract the y's over subtract the x's. So I'm looking at these 2 points. So if I subtract the y's up top, it'd be -3 minus 1. And on the bottom, it'd be -2 minus a -3. Be careful of the negatives. Okay, that's going to be a huge thing when it comes to these problems. In the numerator, I get -4. Now, in the denominator, if I'm subtracting a -3, it's like you're adding it. So therefore, it becomes a 1. That's going to be the slope of LM. Now, because this is showing it's negatively sloped, hey, my number's negative, so good. I have some confirmation that what I'm doing is correct. All right, next, let's find the slope of MN. Let's see what that's going to be for us. So I'm looking at these 2 points. So therefore, it's going to be what? -2 minus a -3, if I subtract the y's, and then 2 minus a -2. In the numerator, -2 minus a -3, it's like you're adding it, becomes a 1. Denominator, we have the same effect, so this is really 2 plus 2, which gives me a 4. Let's take a look at both of these slopes. Okay, they're not parallel. Parallel means they're identical, right? They're not identical. Are they opposite reciprocals? Let's break the word down. Opposite means one's positive, one's negative. What do you think? I know it's hard to see, sorry. Let me make that more prominent. This is negative, this is positive. The opposite part's good. Now the reciprocal part. If I take this guy and flip it, do I get 1/4? I do. So these are opposite reciprocals. Okay? Therefore, LM is perpendicular to MN, which means triangle LMN is a right triangle. Okay. Now, in a future lesson, we're going to be able to prove that a little bit differently. To be honest with you, when it comes to a coordinate grid, this is the easiest approach. You could do Pythagorean theorem, but you would have to find distances here, which would require some distance formula, all right? And then squaring those results, which could get a little tricky. So to be honest with you, this is a nice, easy method, okay? And that's it, guys. So I got 3 problems. You had one where it was kind of a little out of the normal for it, And then we had two problems. Uh-oh. There we go. That was weird. It was the board got stuck. Then we had two problems, one perpendicular, one parallel, and how do we come up with the equation for that? Okay, my notes are online. I have a lot more examples listed so you can practice those out for yourself. If you have any questions, let me know. And until next time, guys, I will see you all in the next lesson video. Thank you.